Homework 1.7, Inequalities, Video 3. Homework due Saturday, May 16, 2020 at 11:59 p.m. Linear Inequalities, Part 2. In the previous video, I mentioned that solving linear inequalities is fairly straightforward, both in the solving and the representing of the solution as both a number line and an interval. However, there are some linear inequalities that have, well, for lack of a better word, issues. Both of these do, a little subtle, but, well, the second one's a little more subtle than the first, but let's take a look at them, starting with A, negative 3x is less than 18. You might be thinking, well, this one's pretty easy. The only reason the x isn't by itself is because it's multiplied by a negative 3. So to get the x by itself, I just have to unmultiply the negative 3, or in this case, divide by the negative 3. And if I do that, I get x is less than negative 6. But what if I told you that that solution was incorrect? Don't believe me? Give me a number less than negative 6. What's the number to the left of negative 6? How about negative 7? If I were to go back to the original inequality, which is here, and substitute negative 7 for the x, I would get negative 3 times negative 7 is positive 21. 21 is less than 18. No, it's not. So what went wrong? How come I divided by negative 3, but the numbers to the left of negative 6 don't make it work? What about the numbers on the other side of negative 6, like negative 5? Well, if I substitute a negative 5, negative 3 times negative 5 is positive 15, which is less than 18. What's going on here? The numbers that are to the left are wrong, but the numbers to the are not solutions, but the numbers to the right seem to be solutions. Now, some of you might be going, I know what's going on here. I remember something that you haven't mentioned yet, but you think I'm about to, and you would be correct. I said that solving linear inequalities is almost exactly like solving equations. Almost. There's two main differences. Number one is how you represent the solution multiple ways. But the other difference occurred in this problem. You may recall a rule that I did not follow, which gave me the wrong answer. The rule being implemented here occurred when I decided to divide both sides by negative 3. And that rule goes something like this. If you divide or multiply both sides of an inequality by a negative number, I didn't leave myself much room over here, but a common catch my breath. If you divide or multiply both sides of an inequality by a negative number, that's what I did here, then the inequality symbol reverses direction. In other words, if you multiply by a negative or divide by a negative, flip the sign. So the minute I brought out the negative 3 and divided both sides by it, the sign in the middle undergoes a change. So this is my little symbol for turn the sign around, a little loopy arrow. So instead of being less than, it's going to flip and become a greater than. I think a lot of you may remember a rule like that. If you multiply or divide by a negative, flip the sign. It's still true. So now the solution, the correct solution I should say, x is greater than negative 6. Everything to the right of negative 6, because it says greater than. Since we are not including the negative 6, we use a parentheses. And so the interval would be parentheses, negative 6, comma infinity, because it goes forever to the right. Parentheses. So it's a little glitch, but it's an easy one to overcome. Just remember, if you divide or multiply both sides of an inequality by a negative number, then the inequality symbol reverses direction. Now, is that going to happen over here? Maybe. This one, what happens depends upon decisions that you make. But there's an issue either way. So let's solve this one. 2x plus 4 is greater than 13x plus 7. You'll forgive me if I keep stepping towards my computer. I'm expecting an email that I need to reply to the moment it pops up. So I may have to pause. I'm not going to pause, but I may just have to check it during the middle of the video. All right, so let's check out 2x plus 4 is greater than 13x plus 7. In the previous video, I mentioned that if you have a variable on both sides of the equation, or both sides of the inequality, then you need to fix that, because you can never get one x by itself as long as there's two of them. So we need to decide which x to get rid of, the 2x or the 13x. Do you remember what I recommended on the previous video? In the previous video, I recommended getting rid of the smaller one because it keeps the x's positive. But let's just say that you're conditioned to having the x on the left side of the problem. So due to that, you would be prone to get rid of the x on the right side. So let's say that you decided to start this problem by subtracting 13x from both sides. Okay, so we pick up a negative where we didn't have one. Big deal, I can handle it, you can handle it. 2x minus 13x's is negative 11x's. Plus 4 is greater than 7. And now we can just push it all the way to the end. Subtract 4, we get negative 11x is greater than 3. And here comes the move that's going to invoke the sign getting reversed. Divide by negative 11. That will cause the sign to reverse. And we get x is greater than, well, we can't do anything with this fraction, but I don't like leaving negatives inside of fractions. There's a rule that says that if either the top or the bottom of the fraction is negative, you can pull the negative out and put it in front. If both sides are negative, then it becomes positive. So we get x is greater than negative 3/11. But that's if you had decided at the beginning to subtract 13x, which isn't wrong, but I want to show you what would happen if you had done this instead. 2x plus 4 is greater than 13x plus 7. Let's pretend at the beginning that you decided, no, I'm going to subtract 2x because I want to keep the x's positive. That crazy man in the video said it's a convenient thing to do. Then we would get 4 is greater than 11x plus 7. And as we proceed to solve, subtract 7 from both sides, we get negative 3 is greater than 11x. Now the division move doesn't involve dividing by a negative, which means we're not going to turn the sign around. And we get negative 3/11 is greater than x. That doesn't quite look like the same answer that I got before. They are the same answer though, because what they're both saying is between the x and the negative 3/11, the x is bigger and the negative 3/11 is smaller. As a sentence, we're just reversing the subject and the object of the sentence. The subject of this sentence is x. X is greater than negative 3/11. But the subject of this sentence is negative 3/11. Negative 3/11 is greater than x, but they both say the same thing. So which answer is correct? Well, technically both of them. Which one do I prefer? This one. Why? Well, there's nothing wrong with this one, but if you were to shade the number line, which direction do you shade? To the left or to the right? Some people would say shade to the right because it says greater than. Something's amiss here. No, something is amiss here. Oh my gosh. I can't believe I let that fester for so long. I'm sure some of you watching this video would probably say, oh my gosh, he forgot to do something. And you're right. But at least I caught it now. When I was over here preaching about flipping the sign, and I even drew the little loopy arrow, you know what I forgot to do? I forgot to reverse the sign. So that last minute and a half of rambling might not have made as much sense. So let's see if I can say it a little more succinctly. Take 2. If you solve it this way, you get this, and these look different. This says greater than, which looks like you should shade to the right, but this says less than, which looks like you should shade to the left. So which one is it? And the answer is you shade to the left. Why? This answer is what I call a backwards inequality. There's nothing wrong with it, but the way you read it, x is not the subject of the sentence. Over here it is. X is less than negative 3/11. X is to the left of negative 3/11. This says negative 3/11 is greater than x. So negative 3/11 is to the right of the shaded part. So how do you shade it? Carefully. Let me erase this number line over here. Regardless of the direction of the sentence, whether the x is the subject or the object. In other words, whether the x is on the left or on the right. You have to be very careful to shade the correct direction. It's easier when the x is on the left. So when I said previously, when you get rid of an x, always get rid of the smaller one. You don't have to. Honestly, in an inequality, you should always get rid of the one on the right. Because then your x is on the left, and when you're done solving, it'll be telling you the correct direction to shade. So we want all the numbers less than -3/11, which are over here. And since it does not say or equal to, we use a parentheses. And so as an interval from left to right, parentheses, -infinity, because that's how far left it goes, comma, -3/11, close parentheses. So as you can tell, some of these inequalities do have subtle issues. I just wanted to make you aware of them.